Hello everyone. In the last class, we have seen about the Gauss law. Sorry, we haven't started the Gauss law, but yeah, we went to the electrostatic part 2 and we have started the electric flux. We have seen the electric flux and we have done some the numerical and some questions we have solved. And now now in the last class we started doing some observation. So we have done one observation. In one observation, we have find that whenever there is a closed surface and we are keeping any charge outside the closed surface, then we can say that the total electric flux passing through the closed surface is always equal to 0. That is the one thing we have done, or one, you can say, one observation we have drawn. Now we are moving toward the next thing, because from there only we will come to know about the Gauss law. Okay, now let us take the second case. This is the first case which you have understand, where whenever we place any charge that is outside the closed surface, then the total flux passing through the closed surface will be always equal to 0. Now second observation, let us consider this is a sphere. Okay, it is a sphere, not a circle. Okay, it is a sphere. It is a sphere, or let me draw a sphere and it will be more clear for you. Let me draw a sphere for you. So you have to treat it as a sphere. It is a, suppose it is a sphere is there. Okay, suppose this is my sphere, correct? This is a sphere, correct? Yeah. Now suppose this is a sphere. Sphere, the radius is given, and at the center, okay, at the center, this is my center, and the radius is r. Suppose the radius is also given, and the radius is r. That is given. Now suppose at the center I keep a charge q. Okay. Now I want to find the flux. What is a flux basically? The flux is closed integration. It is a closed surface E dot dA. Correct? That is a flux only, we know. That is a formula which we have learned and we know this thing. Okay. Can you tell me, for this charge Q, the electric field line will be like this, correct? It will be something like this, correct? It will be like this only, na? This, suppose this is my DE, and not DE basically, suppose it is my E vector, and similarly I will have a dA vector also. So I can say my dA vector and E vector both are parallel to each other, correct? Because dA is nothing but an outward normal, and also you can see the distance of this point from every part on the on the sphere is r. So obviously the electric field will be also same, that is kq by capital R square, correct? This will be the same value. So electric field is constant, so I can take outside the integration, and that is dA. Now what is dA? Okay, what is dA? dA vector will be, what is dA? dA vector will be the integration of this area, correct? dA vector is the integration of this area. What is electric field? That is, you know, that is kq by electric field, you know what is electric field? That is kq by r square, correct? Now what is the area? Area will be 4 pi r square. That is also correct. Yes or no? Now you put the value of k. What is the value of k? 1 upon 4 pi epsilon naught. So 4 pi epsilon naught will cancel, you will get q by epsilon naught. That is a total flux, pi total. So what is the observation we have drawn? If you see the result properly, what you will understand, that the total flux is equal to, this can be written as, my total flux is q inside by epsilon naught, correct? Suppose I increase the radius to 2r. What will, is this flux going to change? No. You can see the flux, the total flux is independent of the dimensions. Okay, the total flux is independent of the dimension. It does not depend upon the dimension. That is the first thing. It is independent of the dimension, correct? So if I increase the radius also, the total flux is again q by epsilon naught. So what is the conclusion? What is the conclusion we have made? The conclusion, let me tell you the conclusion, what we have conclusion we have drawn. So that is the first case, and that is the second case. This is the first case we have seen. If you remember, this is our case 1. You can say this is our case 1. And suppose this is our case 2. In case 2, we have got a conclusion that the total flux crossing, or you can say the total flux through a closed surface is always equal to, that is q by q in. That is, what is q in? Q in is the charge enclosed by the surface. What is I am trying to say? Suppose there is some surface is there. This is a closed surface. Okay. Suppose there is a charge q1 is there, q2 is there, q3 is there, and q4 is there. If I ask you what is the total flux through this surface, then you will say q in by epsilon naught. What is the total charge inside? That is q1 plus q2 plus q3 divided by epsilon naught. q4 will not be here because it is not inside the closed surface. But and you have to also tell me one thing. Phi t is a scalar quantity or vector quantity? Phi t is a, obviously it is a scalar quantity. So that means you have to keep q1, q2, q3 with sign. So here you have to keep q1, q2, q3 with sign. And this is only called as a, this thing what we have concluded here, this thing which we have concluded here, this thing is called as a Gauss law. This is only the Gauss law, nothing but our Gauss law, correct? This is our Gauss law. The total flux passing through any closed surface is given by q enclosed by epsilon naught, where what is q enclosed? Q enclosed is q1 plus total charge that is enclosed by the surface, and you have to keep this charge with the sign, correct? So that is the definition, or you can say statement of the Gauss law. Okay, that is a statement of the Gauss law. Now let us understand it in better way. We have to do the proper analysis. So what we have learned, that is for any closed surface, what we have learned, that is for any closed surface. Closed surface means closed integration. E dot A vector is equal to q enclosed by epsilon naught, that is given by the Gauss law. This is the statement of a Gauss law. In mathematical form I am writing that statement. If any closed surface is there, the total flux flow through this closed surface is always equal to, remember that this is only for the closed surface, that is why it is not for the open surface. Okay, it is for the closed surface. It should be always equal to q enclosed by epsilon naught, correct? It will be always equal to q enclosed by epsilon naught. That is a correct statement, you can say. That is a total correct statement, you can say. So what is the basically Gauss law has said? What is the Gauss? Suppose now let me write the correct, like basically this is our Gauss law. This is our Gauss law. So here what is the E is written? What is that E? This E is what? This E is what? It is what? It is a net electric field. It is a net electric field. For example, I am trying to say, suppose there is some surface is there. Okay, this is my closed surface, and the charge is q1, q2, q3, and q4. Okay, so what is the flux due to q1? How I will write? How I will write the Gauss law? I will write phi electric field due to E1 dot dA is equal to q1 divided by how much? Epsilon naught, correct? Similarly, I will write phi E2 into dA dot dA, obviously this will be equal to how much? That is q2 divided by epsilon naught, correct? Similarly, phi E3 dot dA is equal to how much? q3 divided by epsilon naught, yes or no? Okay. Similarly, phi E4 dot dA is equal to 0 divided by epsilon naught, correct or not? This is the 0 divided. If you add this total, how much you will get? You will get E1 plus E2 plus E3 plus E4 dot dA vector is equal to q1 plus q2 plus q3 divided by epsilon naught, and this is only the Gauss law. If you see, this is only the Gauss law. So you have to understand this E is not normally, it is a net E dot dA vector is equal to q1 plus q2 plus Q3 divided by epsilon naught, that is nothing but Q enclosed. That is nothing but Q enclosed by epsilon naught. That is what I have written here. So remember, this E is not a normally, it is a net electric field on that surface. On this surface, whatever is the net electric field, that's E. This E is not a electric field, it is a net electric field. That is the thing you have to remember. It's very important. Clear? Now I am going to ask you some important statement. You have to tell me whether it is a true or false, because these statements also always come in the some of the exam, in every competitive exam somewhere, like in JEE, NEET, Advanced, everywhere they have asked this statement in one way or in some another way, manner. So let us discuss this statement. The first statement they have given, some write it as some important. I hope you understand what is Gauss law. Gauss law simply states that whenever there is a closed surface and the charge is kept inside the closed surface, then the total flux passing through the closed surface is equal to Q enclosed by epsilon naught, and the electric field which is in the formula, that is nothing but a net electric field. Clear? First, some important statements, okay, regarding Gauss law that you have to understand. Okay, is a common sense, but it is not so much common regarding Gauss law, correct? Gauss, okay. Clear? So let me write the first statement. The statement number 1. What is the statement? Let's see. The statement say, if my Q net means Q in, or you can say Q in, okay, better to say Q in, otherwise people will be confused. If my Q in is equal to 0, okay, through closed surface, through closed surface, if my total charge is 0 through a closed surface, implies, this is a symbol of implies, E is equal to 0 everywhere. It is true or false? You have to tell me whether it is true. Everyone write in their copy whether it is true or false state. We will discuss. Second thing, if my Q in is equal to 0, implies that electric field is 0 everywhere. Otherwise it will be same statement. Let's do one small. Now, okay. If Q in equal to 0, imply that phi net is equal to 0, okay, that is fourth statement. If E is equal to 0 everywhere on surface, everywhere on some surface, implies that Q total equal to 0. You have to tell me which statement is true or false. First statement, read the first statement. What is saying? If my Q net means the total charge is 0. Suppose my total net charge inside is 0 for the closed surface. On the closed surface, I have calculated the total charge and total charge is coming 0. This means that electric field is 0 everywhere. It is correct or false? Think logically. What is a Gauss law? Gauss law statement is closed integration of E dot dA is equal to Q enclosed by epsilon naught, or you can write QT, total charge also by epsilon naught. That is the total internal charge, obviously. So if Q net is 0, that means this thing is 0. So that means this quantity will become 0, means this quantity has to be 0. So it implies that E field equal to 0? Obviously not, because if this thing is 0, the closed integration of E dot dA is 0, na? it doesn't implies that electric field alone is zero. It doesn't mean that electric field alone is zero. Alright, the dot product of two quantity can be zero, na? So that means it is not necessary that the electric field is alone is zero. That is not necessary. So this statement is false. That means this statement is what? It is a false statement. So this statement is false. Correct. Similarly here, if my Qin is 0, E equal to 0 everywhere, it is true or false? Again it is the same false statement. Why? Same logic. Correct. If my Qin equal to 0, my phi net is 0. Obviously, if my Q is 0, then this is the flux only, na? So that means total flux is 0. That is a true statement. If my electric field is 0, then this thing will be 0. Then obviously the total charge will be 0. So that means this is also a true statement. So these are the important statement. If these statements are clear 110%, then we will proceed further. Let's read this statement and see how we have go to the conclusion. Just read it once and try to understand. If it is clear, we will proceed further. Clear? Okay. See, one more thing I am going to tell you. See, we use Gauss law, that is okay, but it is not advisable to every time, that it is not possible that every time you are able to use the Gauss law. Basically, Gauss law is invented to calculate the electric field. Okay, to do the calculation of electric field, we have invented the Gauss law, but it is not possible that you can apply the Gauss law everywhere, because it is a type of law. It is applicable in certain conditions. If certain conditions fails, then you cannot apply a law. Okay, that is a property of a law. That is, law cannot, it is not sure that you can apply the law anywhere or every time. Okay, so now let us take some examples. Okay, yeah, let us take some examples. Suppose this is a sphere, hemisphere. There is another hemisphere, and there is a one more hemisphere, but there is a difference between these three, these three hemisphere. What is the difference? Let's see. The first case, this hemisphere is closed. Okay, or let me do one thing. Okay, so suppose there is a hemisphere is there. Okay, that is the first thing. Suppose there is a hemisphere. Correct, this is the one hemisphere. Okay, this is a hemisphere. Remember this is not a normal sphere, it is a hemisphere. Okay, it is a hemisphere. Similarly, we have another hemisphere here, and similarly we have a one more hemisphere here. Okay, suppose these are the three different hemispheres are there. Now what is my question? Let's see the question and just try to understand it. What is the question try to say, and what is given, and you have to give me the answer. Okay, if you understand the previous three statement, you can directly answer this question without any problem. If you have understand the three statements properly, then you can answer this statement. Let us see what is the statements says. The first condition, the charge is placed just outside here, just outside. This is my center. It is, the charge is placed just outside. Here the charge is placed just inside. Here the charge is placed just inside. Okay. Just inside. Here the charge is placed just inside. And here the scene is different. Here what we have did, in this case, this is a open, and suppose the charge is placed at the center Q. You have to calculate the flux through this. What is the total flux? In this case, the charge is placed just outside and it is a closed surface. So what is the total flux? The total flux will be how much? 0. Obviously, we have seen the conclusion. here it is placed just inside and it is a closed surface. So what is our total flux? We have also seen that is how much? Q by, what is the total flux? It is Q by epsilon naught by Gauss law. Now here, can we apply the Gauss law? No, because it is not a closed surface. But one thing is that if we do one thing, what we can do, if we draw a symmetrical surface like this, because the charge is placed at the center, if we draw a symmetrical surface like this, okay, a symmetrical surface, what type of surface? A symmetrical surface like this, okay. If we draw a symmetrical surface like this, then it is possible that then total flux will be Q by epsilon naught, correct? If it is a symmetrical sphere, then the total flux is Q by epsilon naught because it is a closed surface. Now it is placed at the just like into the symmetrical way. Whatever the flux going through this surface, the same amount of flux we can go through the same surface, we can say by the symmetry. So if the total flux is Q by epsilon naught by total part, so half of the part, what is the total flux? The total flux will be Q by 2 epsilon naught, simple. Yes or no? I hope it is clear. So this is how you approach the question. So there is an approach for solving the questions in the Gauss law, correct? So have you understand? In this case 0, in this case Q by epsilon naught, and in this case Q by 2 epsilon naught, correct? Any doubt? Clear? Okay. Let's go for one more question. So I am building your concepts, okay? Just try to build your concepts. So let's take one more example. Yes. We can do one more thing. Suppose this is a square plate only, okay? This is a square plate. It is a square plate. It is not anything else. It is a square plate. Let me draw it properly. Okay, this is a square plate, correct? This is a square plate, and suppose from the center C, at a distance of a by 2, we have placed the charge Q here, okay? So some flux will be going through this surface you have, and this is a square plate. Of side A, correct? You have to find the total flux through this surface. What is the flux going through this surface? How to calculate? First try to think how I can make this as a closed figure. What I have to do to make it as a closed figure? If I want to close it, if I want to close this charge, because from closed surface we know the total flux is phi by epsilon naught, Q by epsilon naught. So what I have to do? I have to make a cube of side how much? A. I have to, if I want to close this charge, I have to design a cube. I have to design a cube of side 2A, correct or not? I have to convert this into a cube. Where the charge is placed, the charge is going to be placed at the body center of the body, and the distance is a by 2, correct? This is the thing. So if you see here, if it is this case, then in that case the total flux will be Q by epsilon naught. So, and this is a one face of the square. If you see, this is a one of the face of the cube, correct? So from 6 faces, the flux is Q by epsilon naught. So from one face, what is the flux? That will be Q by 6 epsilon naught. So that is the correct answer. Clear? You have to use the geometry concept here in Gauss law. You have to use the geometry concept. Clear? There is no doubt. Clear? Okay. Let me take one more example. Okay. Yeah. Suppose this is a cube and everything is same. The side is A, side is A, and suppose the charge is placed suppose the charge is placed here. Yes, I place the charge at this corner. You have to calculate the total flux. What is the total flux through this cube? You have to calculate. Just think about it, how to do this. how to cover this charge to form a closed surface. How many cubes I will require? How to I will cover this? Just try to think this. Think that. Try to imagine your room. We have on the one of the corner we have placed the charge. Correct. So now you have to tell me what is the total flux through this. First you tell me how will you cover this. Let's see the solution on the next page. First you will tell me how will you cover this basically. So for that you will need a one bigger cube, correct? One very big cube. In that big cube you have to keep a one small cube, correct? In that big cube you have to keep a one small cube, correct or not? I think I am saying correct only. Yes or no? Array, to cover this cube you have to keep a like this. Okay, I have to keep a small cube, and at this point we have a charge. I hope it is visible to you. Yeah, it is visible. So I have to, here I have a charge cube, and what is the side? It is very bigger. If I try to reduce the, it's very bigger. Much of big. Now it is okay. So what is the side of this cube? The side of this cube should be 2a. If this side is a, yeah, the side of this will be 2a, and the side of this is a. It doesn't look, but yeah, try to like compare it. The size, this side is 2a and this side is a. So if now I will ask you, and how much cube you will require for covering this inside this bigger cube, you will require this 8 cubes in front, then here, then one more here, then like that we have above also. So total 8 cube you will require to bring this charge at the center and cover it properly. So we require 8 cube. We require 8 cube. Okay, 8 cube, and the flux will be through one cube will be q by 8 epsilon naught. That is a flux through one cube. Flux through one cube, correct? I hope it is clear. This is a flux through what? I am correct or I am doing something wrong? Yeah, correct only. Yeah, it is correct. So yeah, we require total 8 cube to cover this cube, correct? Okay, 8 cube or 6 cube? 1 minute. 1 cube here, okay, then 1 cube, 4 cube will be there, and 1 2 3 4 4, yeah, it's correct. 8 cube will require, it will cover. Now the thing is that the flux through one cube will be q by I hope we are doing something is wrong, because if it is there, 8 cube will be there. No, 1 2 3 4 5 6, yeah, correct. 8 cube will be required. Now let us think here. We got that we need a total 8 cube. It is clear. Now just think, suppose we have a charge at one of the corner. Now we have how many faces we have then? then we have this face, and top and the bottom. Now we can see if the charge is placed at the corner, then the electric flux through this surface and this surface and this surface will be 0. Why? Because the electric field line is going to graze the surface completely. It is going to just touch the surface. So obviously the dA vector is going to be perpendicular to the electric field line. So through these three surfaces, the electric flux will be 0. Correct? Okay. Now the with now another three surfaces will be left only. That one, and that one. Correct? So only three surfaces are left. So total flux will be how much? Total flux will be, then in that case it is Q by 8 epsilon naught into 1 by 3, that is Q by 24 epsilon naught. That is the answer. Correct? So this is how you have to think. One more way to think it, you know how, like if the charged particle is placed at the corner, how much is the partition is there, how much part of the particle or how much part of the particle is present inside this room? 1 by 8th part. So the contribution is 1 by 8th. I think you have learned in solid state in chemistry chapter 1, class 11. If the particle is placed at the corner, the contribution in the effective cell is 1 by 8. So the flux will be Q by 8 epsilon naught. Now how this 3 is coming, that I explain you from this diagram, that from three surfaces the electric flux will be 0 because they are what? The electric field lines are just touching the surface. So the dA vector will be perpendicular. But only three surfaces will be there where the electric field lines are crossing. 1, 2 and 3. That is the three surfaces. So that is why we are getting the electric flux from the three surfaces. Clear? I hope it is clear now. So now we can move to the next thing. So these are the different types of questions we will have. Okay. I hope it is clear. Basically, if the charge is placed at this corner, so obviously the three surface flux will be 0. This surface, this surface, this surface. But the three surface will be left. Which three surface will be left? The bottom will be left. Correct? Similarly, think it like a cube. Now, if suppose this is a cube, you can think this surface and this surface flux is going to be 0. But other three surfaces are left now. That two sides are left and that bottom is also left. That two sides are left and the bottom is left. What I am trying to say, the top surface, this surface and this surface, the flux is 0 because the dA vector is perpendicular to the electric field. But if you see the bottom surface, this surface, okay, and this surface, so these three surfaces, the flux is not 0. So in that is the three surfaces which are contributing here. I hope now it is clear. Okay. Let's take one more problem. So let us consider there is a, like, try to understand this problem first. What is that problem is saying? Suppose there is a sheet is there. Okay, this is a sheet. Okay, and it is going up to infinity. Means what I am trying to say, like this sheet is going up to infinity. Okay, this is not ending here. It is going up to infinity like that. Okay, it is going up to infinity. Suppose this sheet is going up to infinity. Minus infinity to plus infinity. Correct? This is the sheet. It's going up to infinity of, and the thickness, this length is A basically. So if I place this sheet, this is the sheet like this. If I place like this, you will going to see only the straight line. Correct? So suppose this is a straight line, and from the center at a distance of root 3a by 2, I placed a one charge q. You have to find the flux through this plate, through this surface. How to calculate the flux through this surface? Basically, try to understand. I have taken this sheet and I have kept in like this manner. Correct? So that's why you are able to see only this thing. The side length is how much? A. Okay, now you have to calculate the flux through this surface. How to solve? How to solve? Try it. Have you tried? So let's see the solution. If you see here, this side will be how much? A by 2. This side will be how much? A by 2. What is this angle then? A by 2, it root 3 by 2, tan theta is equal to. So it will be how much? I think 30 degree. Yes or no? So this angle will be also 30 degree. So it will be what? It will be 60 degree total. So it will be hexagonal. Hexagon, yes or no? So this I can make into a hexagon. Correct? So if it is a hexagon, then the total flux now the total flux through this hexagon is q by epsilon naught, and from one surface it is q by 6 epsilon naught because it is equal distribution. Correct? Simple. Are there are 6 faces are there na? From total hexagon q by epsilon naught, from one face q by 6 epsilon naught. Simple. Just you have to use the geometry. It's geometry thing. Okay, you have to use the geometry. Clear? Shall we proceed further? Till now anyone have a doubt here? Please tell me. No doubt? Okay. So now till here we have seen some numerical and we have built some confidence on solving the question on Gauss law. Now basically why the Gauss law was invented to do the calculation of electric field for the different geometries. That is what we have invented the Gauss law. Now first we will see how the Coulomb's law, basically first the Gauss law was invented, then we get the Coulomb's law. We haven't get the Coulomb's law then Gauss law. No, first we invented the Gauss law, then from Gauss law we developed the Coulomb's law. So how it is developed, let us see. Suppose, so basically what you have to do always for calculating electric, what are the steps we have to follow to calculate the electric field by the Gauss law? Steps to find electric field by Gauss law. What are the steps? First step is what? Step 1. Draw the Gaussian surface. Draw the Gaussian surface. Gaussian surface means the surface where the electric field is where the electric field on the surface is constant. Okay. Draw the Gaussian surface. For in your course it will be like that only. Gaussian surface means surface where electric field is uniform. Correct? That is a type of Gaussian surface. Like for linear charge, if there is a linear charge, what is a Gaussian surface? You tell me. If there is a linear charge density, what will be the Gaussian surface? Suppose it is a linear charge, then the Gaussian surface will be a cylinder. Correct? Similarly, if suppose there is a point charge q is there, what is a Gaussian surface? It will be a sphere. Correct? It will be a it's sphere. Sorry. Yeah, it will be a sphere like that. Clear? So this is the how you have to do the Gaussian surface. Now second step is very simple. You have to simply apply the Gauss law. Gauss law is that E dot dA is equal to q enclosed by or q in by epsilon naught. That is the second thing you have to apply. Apply this. That is the thing you have to do. You have to apply this. Simple. These are the two steps you have to follow every time. Just draw the Gaussian surface, and just for your syllabus always it will be a cylinder or a sphere, not more than that. For your syllabus it will be always a cylinder and a sphere, and will be always try to take the Gaussian surface means where the electric field is constant on that surface. Simple. In your syllabus it cannot go beyond that. Simple. Okay, it will not go beyond that. Now let us first derive the Gauss law. Sorry, let's derive the first derivation. Just I am doing for your understanding, that is Coulomb's law. Coulomb's law by Gauss law. That is the exact thing which has been done in the papers. If you see the research papers, they have done this thing only. They have first derived the Coulomb's law, and then they have written the uh, first they have done the Gauss law, then they have written derived the Coulomb's law by using the Gauss law, correct? So let us take a point charge q plus q, and for this what will be my Gaussian surface? It will going to be a sphere, okay? It will going to be a sphere, correct? I hope no doubt it will be there. It will be going to be a sphere having radius r. Okay? Any doubt? Okay. Or so radius is r. Now you tell me what is the direction of electric field will be. The electric field will be like this, correct? It will be something like this everywhere. So the electric field will be, and it will be constant everywhere, correct or no? It will be constant also. And what is the dA vector? The dA vector is also in the same direction of the electric field. This is my dA vector. So now you have to write the formula. E dot dA vector is equal to q enclosed, that is q by epsilon naught. So E dot dA means E dA cos theta cos 0 degree integral of q by epsilon naught. Now cos E you take outside, you will get what? dA, that is q by epsilon naught. Now what is the integration? Because E is constant, so that's why we have taken outside. What is dA? dA will be area of the Gaussian surface. Remember, this is the area of the Gaussian surface, not the area of the whatever geometry you given. It is the area of the Gaussian surface, that is 4 pi r square, that is q by epsilon naught. So from here we will get my electric field is equal to q by 4 pi r square into epsilon naught, or you can say q by 4 pi epsilon naught into r square. So see, we get a Gauss law, or you can say we get a Coulomb's law, sorry, we get a Coulomb's law, because this is the electric field. Simply you multiply it with the charge, you will get the Coulomb's law. So that is how we have derived the Coulomb's law from the Gauss law, correct? That is the first derivation. Just for understanding, this is how we are going to do the all the derivations. Clear? Till here anyone have a doubt? Please tell me. If you have anyone, if anyone have a doubt, please tell me. Any doubt is there? Okay. So our next derivation is, have you remember what is the electric field due to the infinite wire? Electric field due to infinite long wire. What is the electric field due to the infinite long wire? Can you tell me? That is 2k lambda by r. Okay, so let's do one thing. Let us prove it by using a Gauss law. Okay, so suppose this is my infinite long wire, okay, and suppose at a distance r I want to calculate the electric field. So what is my my Gaussian surface? My Gaussian surface will be going to be a cylinder, correct? Let me see if there is cylinder or not in 3D. Cylinder is there. Why I have to? Yeah, so suppose this is a cylinder. If it is not looking straight, treat it as a straight only. It is straight. And suppose the charge is lambda coulomb, charge density is lambda coulomb per meter. Suppose the length of the cylinder is L. Okay. So first you have to tell me integral. What I have to do? Integral E dot dA. Electric field will be like this, correct? Yes or no? Electric field will be like this only. That is okay. Yeah. Now E dot dA is equal to Q in by epsilon naught. First thing you have to tell me, that is on this surface the electric field will be constant, correct? That is obvious. What is dA vector? See, if you see, there are the two surfaces are there. One is flat surface in this case, and we have a one, like we have basically a curved surface and two flat surfaces are there. The two flat surface and one curved surface. If you calculate for two flat surface, you will get E dot dA is equal to 0. Why? Because the electric field in this direction, for this surface my dA vector is like, sorry, for this surface my dA vector will be like this, correct? So what is the angle? Angle is 90 degree. E dot dA will be 0 na. Similarly here also E dot dA will be 0 because it is 90 degree, correct? So for this E dot dA will be equal to 0. Have you understand why it is 0? Because the angle is 90 degree. So for curved surface only you will get. Now for this surface dA vector is in this direction, and for this surface the dA vector will be in this direction. So this is my dA vector, correct? And for this surface this is my dA vector, correct? So I will get what? E close integration of E dA into cos 0 degree 2 times that should be equal to q in by epsilon naught. Now what is electric field? I have to calculate. Electric field is constant on this surface, so I can take it out from the integration. Now what is the integration of dA? dA integration means integration of this curved surface area. That will be obviously 2 pi r into height L. Now what is the charge within this length? See, charge density, we know that charge per unit length is lambda. So what is the charge in this length will be? That is how much? Lambda into L, correct? By epsilon naught. So from here LL will be cancelled out. If you calculate, you will get E is equal to how much? Yeah, it will be how much? I think sorry. Oh sorry, one mistake I did. It should not be 2 na, because there is only one curved surface is there. It's not a 2 curved surface. On both the side it's only one curved surface is there. Okay. So yeah. So this will become how much? Sorry, lambda upon 2 pi epsilon naught into r, correct? This is the thing. Now you just do one thing, multiply 2 here and multiply 2 here. In both numerator and denominator you will get 2k lambda by r. So that is the electric field. We have know this electric field earlier also, and now we have proved it by the Gauss law, that the electric field due to an infinite long wire at a distance r from its axis will be equal to 2k lambda by r, correct? Any doubt here? Till here anyone have a doubt? Please tell me. Please tell me anyone have a doubt till here, because these proofs are important. Okay, please tell me whether this whether anyone have a doubt. Clear? No doubt? Okay. So till now we stop here. In the next class we are going to do some more derivation of hollow wire and everything. I hope you enjoy this session and you understand something and you have cleared the sum of the doubt regarding the Gauss law. In the next session we will start the different geometries and we will do some derivations and we will understand the solid wire and hollow wire and everything. Till then, take care, goodbye, subscribe it, like it, share it. Thank you, have a nice day.